This is section 10.4. We're going to be graphing parabolas. This is the last of the conic sections that we have to graph. We have graphed parabolas before. In fact, we graphed equations that looked like this, where we have a number times x squared plus a number times x plus a constant. And if you recall, if the leading coefficient, that's the number times the x squared, if that's positive, then the graph opens up, and if it is negative, then the graph opens down. You may also recall we talked about the vertex and the minimum or maximum value. We're going to talk a little bit more about that later on in this section. But for now, we're going to have y is equal to a number times x squared, and just you need to know that that opens up or down, and x is equal to a number times y squared. That's going to open left or right. Now, if that number is positive, it's going to open up in the positive direction. Notice these are positive numbers over here. And if that number is negative, then it's going to open to the left, which are negative numbers. All right, so let's do a couple examples. I have an x squared. X squared tells me that I need to go up or down. And I have a negative 2, which tells me that I need to open down. I'm not shifting any of these, so I know it has to go like this in some way. So to figure out exactly how narrow or how wide that parabola is, what I'm going to do is I'm going to plug a value in for x. I'm going to find a point. I'm going to choose any number I want to for x. It doesn't matter which value you choose. Since it doesn't matter, in this particular example, let's pick x equals 1. 1 is the second easiest number to plug in, the first being 0. So what we're going to do is we're going to plug in x equals 0 and find out what the y value is. So we have negative 2, so this is coming from our equation here. 1, we plugged in 1 for x. So remember, you do the exponent first. 1 squared is 1, and negative 2 times 1 is negative 2. So right now I have the original x value that I chose, which was 1, and the y value, which I found, was negative 2. So I'm going to plot that point, negative 1, negative 2. And I said that the parabola has to open down. Since the parabola has to open down, and if you recall again about parabolas, they have to be symmetric, what that means is that if I have a point over here, I have to have a corresponding point on the other side over here. So here is my parabola. All right, let's do this example right here. X is equal to negative 1/3 y squared. Okay, I do have a y squared. Y squared tells me I have to open to the left or to the right. And since my 1/3 is negative, that means I'm going to be opening up something like this. It's going to open up to the left. Okay, again, my center is at 0, 0. So to figure out how wide or narrow that parabola is, I'm going to choose a value to plug in. Now, last time we picked a value for x. This time I'm going to tell you to pick a value for y. Doesn't matter. I'm going to choose a value for y. And in fact, I'm not going to choose 1. I'm going to choose, actually, 3. And I will tell you why I chose 3 instead of 1. If you take a look at this number right here. Well, since that's in the denominator, that's a fraction, what I'm going to do is I'm going to choose that number. Now, if that had not been a fraction there, it wouldn't matter. I would have picked 1. But since that is a fraction, I'm going to choose 3. So, since I chose a y value, that means I have to find the x value. And I'm going to plug that in. So I have negative 1/3 times 3 squared. Order of operations says you have to square the, you have to use exponents first. So negative 1/3 times 3 squared is 9. And if you recall, a fraction times a whole number, I have to put that over 1, multiply the tops, multiply the bottoms. So I have negative 9 over 3, which will reduce to negative 3. Notice, since I chose my original y value as the denominator, I now do not have to worry about a fraction that I'm graphing. So my x value is negative 3, and my y value is positive 3. I'm going to plot that point on here on my graph. My x value is negative 3. My y value is positive 3. Okay, and remember, I told you that it had to open somehow or another open up to the left. So this point right here is going to have a corresponding point over here somewhere. And if you look, I went 1, 2, 3 up, and I went 1, 2, 3 to the left. So that means I need to do 3 down and 3 to the left. And there is my corresponding matching point, which will give me my parabola. All right, determine which direction the parabola opens. Okay, so first thing you have to do is check for an x squared or a y squared. So if I have a y squared, I know y squareds are either going to open to the left or to the right. Since the number in front of the y squared is positive, it's going to open in the positive direction, which is to the right. Now let's take a look at this one. This one is not set up for us to do very easily. So what we're going to have to do is figure out whether we get our x by itself or our y by itself, or in this case we have x's and y's on the same side. So do we need to get the x by itself, or do we need to get the y by itself? What you're going to do is you're going to look for the squared. What variable is squared? In this case, the x, and that needs to go on the right-hand side. So since the x squared has to go over here on the right, I'm going to take the x over as well. So we're going to leave the y on the left, and the x squared and the x have to go to the right-hand side. So subtract x squared, add x. Subtract x squared, add x. Negative x squared plus x plus 1. Okay, if you have an x squared, that means it's going to open up or down. And since the x squared is negative, it's going to open down. I will have you do example 3 and 4 on your own. Give it a try, see what you can come up with. You will have at least 1 or 2 problems like what we're going to talk about next on the semester exam, so you do need to know how to do this. You have to be able to distinguish looking at the formula or the equation whether or not you have a circle, ellipse, hyperbola, or parabola. So here's how you can tell by looking at the equation what the graph is going to look like. Remember, with a circle we have x squareds and y squareds. We're adding, right, and it equals some number. So x squared plus y squared is equal to 10. Now, every once in a while they try and trick you and put a number in front of the x squared and the y squared. So they could say 15x squared plus 15y squared is equal to 1. It's not in the standard form, but notice that the numbers, the 15 and the 15, are the same. So that tells you that you have a circle. And let's talk about the ellipse. Ellipse is, again, you have addition, but instead of having, let's say, 15x squared and 15y squared, let's suppose you had 9x squared and 15y squared. If these two numbers are different, that tells you you have an ellipse, and quite often they will put numbers on the bottom, but again, you're checking for whether or not these two numbers are the same. So if they're different, that tells you you have an ellipse. All right. Hyperbola is easy. That's the only one that has an x squared, y squared, and subtraction. Subtraction. So you're looking for subtraction with a hyperbola. Parabola is also easy because only one of the variables is squared, the other is not. So let's do a couple examples. I have an x plus 4 squared plus y minus 2 squared. So they're both squared, so it's not a parabola. We do have a plus, so that's going to be either a circle or an ellipse. So is there any number down here, or is there any number right there for the coefficient? Since there's no numbers, that means they're ones, and since they're all ones, they're all the same, that tells me that I have a circle. So the really only tough one is determining whether or not you have a circle or ellipse. Hyperbola is easy, so is the parabola. Speaking of parabolas, I've got a y and I've got an x squared, but I do not have a y squared, so that automatically means a parabola. My y is not squared, but my x is, so again we have a parabola. I've got an x squared, I've got a y squared, I've got a plus, so that tells me either circle or ellipse. Check to see what the numbers are in the denominator. Check to see what the numbers are in front. So this is a 2, this is a 1. The numbers are different. That means I have an ellipse. An example of a hyperbola, I've got a y squared, I've got an x squared, and subtract hyperbola. All right, a little bit of review. This is on your semester exam, so you do need to know how to do this. We're going to find the maximum or minimum value, and remember I said we've done this before, just it's been a while. What we're going to do is we're going to do negative b over 2a, and that's going to give us our x value, which is not what we're trying to find. When it says maximum or minimum value, what we're really trying to find is the y. So you're wondering, why are you finding the x? Well, we can't find the y until we find the x, so we actually have to find the x first. So, if you recall, our equation is 3x squared minus 6x plus 2. The a is the number in front of the x squared, in this case it's 3. The b is the coefficient for the x, in this case it's a negative 6, be careful with that negative. And the c is the constant, or 2. So we're going to plug it into negative b over 2a. That will give us our x value, which is not our answer. So our b is negative 6. The formula also has a negative. You do need both of them. Over 2 times our a value is 3. Negative negative 6. Those become positive 6. 2 times 3 is 6, and 6 divided by 6 is 1. This gives us our x value, but that's not what we're looking for. We're looking for the y value. So we've got to take this x value and substitute it in for x. So 3 times 1 squared minus 6 times our x value of 1 plus 2. 3 times 1 squared is 3 minus 6 plus 2. 3 minus 6 plus 2 gives me a negative 1. Final answer, negative 1. I'm not going to work this out. You can ask questions in class, but if you are going to multiply these together, which you have some in your homework, again, this is some review, I do want you to use the box, and you're going to fill in the whole thing, but just as a reminder, when you multiply I times I, you get I squared, and again, as a reminder, you have to replace I squared with negative 1. So you're going to take negative 1 and replace your I squared. Again, some review. When you're solving with a square root, you got to get the square root by itself, so the 1 has to go on the other side. Square root of 3x plus 1 is equal to 5. Square both sides to get rid of the square root. Opposite of square root is square. 3x plus 1 is equal to 25, and you should be able to solve it from here. And divide by 3, x equals 8. And I am going to stop here. Let me know if you have any questions in class. And this is section 10.4.